Hello everyone, my name is Alexander Ilic. I'm a senior BIM manager and product specialist at Bexel consulting company, and today I will try to give you an insight about integrated BIM workflows and IFC based workflows within Bexel Manager application. At the beginning, just a few words about our company. We are software vendors and a construction consultants company with years of experience within both developing the software and offering construction consultants. We're offering a range of BIM products from Bexel Manager, Bexel Portfolio Manager, Bexel Viewer, and we are a multinational member of buildingSMART International. Our clients are well-known construction companies around the world. Our software user interface is localized in 12 languages with 3 more languages in preparation. We're proud to say that when we analyze the structure of the projects where our software products are used and the structure of the stakeholders that are using our software solutions, we can see a big diversity. That means that our software solution is well tailored for different needs of different users within the industry. When it comes to integration, we are open BIM software. That means that we can import and export IFC and BCF formats, and we can connect with all open BIM softwares. But we also have a direct connection with Autodesk Revit and Navisworks, which allows us to integrate even with the softwares that are not supporting open BIM format. Today we will see the integrated BIM workflow, which will cover the use of Bexel Manager application, Bexel Viewer, and Bexel Portfolio Manager application. This is our basic software architecture, our main software ecosystem, which shows you all the functionalities and all the modules that are included in our software solution. It is showing the relationship with other open BIM platforms and other open formats as well. So what makes a difference between any 3D model and BIM model is the model data layer. But having the data does not guarantee success. It is often the case that you have incomplete, inconsistent data that you just cannot use properly. In the first place, that is project-specific data that was not integrated or structured properly. Integrating such data often requires significant time, resources, and discipline, and if quality control process was not performed properly, you can end up with fragments of project that could hardly be used for successful BIM implementation. On the other hand, almost every BIM model in the world contains a lot of reliable, standardized, well-structured information that is often overlooked, and yet it is very easily and intuitively integrated in BIM model. IFC properties, categories, families, buildings, all of this information represent robust, reliable information that, with the right tool, could be utilized to serve as a basis for good BIM analysis. Today's integrated workflow will consist of a few major steps. So at the beginning, we will start with enriching the model with the data, automatically enriching the model with the data using the existing data of the model, QTO creation and generation of cost work breakdown structure. After that, we're gonna go through the process of automated generation of BOQ based on previously prepared work breakdown structure. Then we're gonna go to the process of intelligent scheduling, where we're gonna use zones and methodologies to automatically create 4D, 5D schedules. After that, we'll go through the process of schedule optimization, and at the end, we will wrap up everything with the progress tracking procedure using this automatically created 4D, 5D schedule. So let's start with the first step of our integrated workflow, which consists of enriching the existing data of the model based on the robust, already present data within the model. For this, we're going to use configuration documents or templates, which will be loaded to the model through OpenAPI add-in, and based on the rules that are defined by the user, model will be enriched with additional layer of information that will serve as a basis for our work breakdown structure. So our goal here is to try to enrich model information layer with additional information, but based on the existing information. So based on the category name, system group name, structural element properties, and even story elevation in some cases, we're going to try to enrich this model with additional set of properties that will classify all model elements into 3 standardized classification systems. Even the whole process that is for now based on a simple Excel spreadsheet template, knowledge template that is, I would say, most intuitively acceptable for the engineers, could be in the future developed for, let's say, using the BSDD enrichment and some even more complex ways of enriching the model data based on the existing IFC parameters. So we will automatically try to populate these classification codes and classification descriptions into existing model. So after this whole process is complete, using very simple add-in, we can just select one of the elements and just see all the populated information that was predefined using the knowledge template that were just loaded during this enrichment process. Of course, we can also visualize this information by simply creating a custom breakdown structure, which will actually visualize the populated data and which will just show us visually where the certain codes and how these certain codes are distributed along this specific model that we were using as the basis for our BIM analysis. So basically we can see for every single value of uniformat assembly code different color coding. Of course, we have some undefined values because those are some existing structures in the model which should not be coded basically, but we can also pinpoint and just find some of the codes and check if these codes correspond to classification category for this specific model. So after we were able to populate classification system information into the model, the next step is to utilize this newly added layer of information, so that use this information to develop a cost classification structure within the BIM model based on the newly added information. So this is going to be done through a smart cost management process within Bexel Manager, which allows user to define work breakdown structure and using additional knowledge templates for the cost classification, naming and rules of measurement information, creates a complete cost classification based on the information within the model. So we're going to use the same model that we just enriched with the new cost classification codes, and based on these codes we're going to be able to develop QTO, which will serve as the work breakdown structure for our cost classification. So using the substring command, we can just utilize the uniformat assembly code in this case that was populated with the enrichment add-in, and we can build the hierarchy, the structure of our groups of works, the structure of our future cost classification, and we can then use that structure as the basis for development of our cost classification. And as we can see, user can visualize this work breakdown structure and select different elements in the work breakdown structure hierarchy. So the next step is creation of cost classification out of the created work breakdown structure. So we're going to create new empty cost classification, and we're going to start creation wizard. So right now we're going to just choose the QTO that was created for work breakdown structure for our future classification. Then we have ability to choose the coding system for our new cost classification. We're going to again utilize the information that was enriched at the beginning with our add-in. We can choose the coding on the cost item level. We can choose classification naming, and we can choose a template for this. In this template that is based in your template directory on your computer, or in the future in the form of the cloud-based knowledge database, you're going to be able to specify the naming and description for your coding system, and you can always use it during the creation of a cost classification. You can choose the cost item name, in this case from the quantity takeoff or the work breakdowns directly. And user is able to specify rules of measurement directly from the QTO that served as a work breakdown structure, or again from the template that is placed in the knowledge base. In this template, again in a very simple way, you can predefine based on which parameters, so let's say IFC parameters or category or structural element property. You can predefine a quantity formula, you can predefine quantity type, you can predefine quantity unit, and what you can also do, you can predefine additional cost items, additional activities for certain types of works, like let's say concrete works, which could have added additional cost items, additional level of cost structure creation based on the predefined template. After this template is loaded, you just complete the action and you get your cost classification fully created with all the cost and classification items, with all the element queries that will allow connection of the cost items and the model elements, as well as quantity formulas and quantity units predefined based on the knowledge template. Every cost item has defined rules of measurement, has defined naming and description. The only thing that is lacking is the information about the unit prices. So this cost classification could be exported into Excel and it could be populated with the prices in simple Excel spreadsheet. In the future, we will also develop a system in which you will be able to just reuse this cost classification on the next project and just update the information. So use the existing information, including the unit prices, and then just update newly added families and newly added types of works to the existing cost classification that will be enriched itself on every new project. After importing cost classification that now includes the information about the unit prices, user is then able just to assign this newly created cost classification to existing model elements. So all the elements of complete BIM classification are here. So we have element query, we have rules of measurement, we have unit prices, and with the assignment process, we're going to just automatically calculate all the quantities and calculate complete prices for all the elements in the model. And now we're able to just see and manage complete cost information on this project. We can see the cost by groups of works, and we can see to the lowest level of cost classification organization as it was defined through the smart cost management process. After defining complete BIM cost classification based on the enriched data from the beginning of the process, the next analysis that we're gonna try to develop here is the 4D analysis, or integrated 4D 5D analysis. So to do this, we're gonna use advanced scheduling engine, intelligent scheduling engine, which is available in Bexel Manager, which will allow us to now utilize the information that was added during the cost classification development and to use it for the so-called methodology creation. That means the work sequence definitions of our schedule, and combine it with the zone definition or the spatial distribution of the works on our model, and trying to create schedule automatically. So the main idea behind intelligent scheduling engine is to automate creation of the schedule by defining methodology or work sequence definition of works based on the cost classification that was created in the project, and that user defined spatial project organization or spatial works distribution based on the spatial parameters of the model. As a result, with a combination of the zones and methodologies into a so-called creation template, we're able to capture experts logic, to capture logic of organization of the project schedule, and to generate the schedule itself based on this logic. So the process starts with a definition of zones, or definition of the spatial distribution of works in the model, and you can rely upon the spatial parameters or spatial information that is available within the model. So you can rely upon the phases, rely upon the defined buildings, rely upon levels or building stories defined, and using Bexel Manager, user is able to define relationships between those spatial attributes, between those spatial parameters of the model, by simply going to the zone editor and defining so-called zone nodes and defining relationships between different zones. So you can define relationships between buildings, relationships between phases of the project, as well as relationships between vertical spatial elements or vertical spatial distribution on this project or project stories. And on the other hand, within methodology editor, user is able to define a work sequence organization based on the newly created cost classification. So in this case, user is able to just refer to the groups of works within cost classification and to define relationships between those groups of works, so defining the type of the relationship and defining basically the work sequence between different groups of works within project classification. Of course, these methodologies could be predefined, and they could be also developed and saved within the knowledge database. So these predefined methodologies are completely applicable for, let's say in this case, uniform-based cost classification. So on every future project where you develop uniform-based cost classification, this once developed methodology could be used for any future uniform-based project. So whether you're using your own developed methodology or a predefined methodology from the knowledge template that you're just applying to this project and to this standardized cost classification, you're able to define a creation template which will combine methodologies and zones developed from your project and available from your knowledge base. And with this template, you're going to be able to create schedule structure automatically. So very simple and pretty similar manner as with the cost classification. You're going to develop new schedule. You're going to define the cost classification that is corresponding to the schedule and to the methodology that you used for your template, and you're going to simply just load the template. And basically in a matter of seconds, intelligent algorithm based on your inputs, based on your templates, will define a complete schedule with all the tasks and all the relationships already prepared. So the complete schedule structure is visible. All the tasks have default duration of 40 hours, and all the tasks could be seen throughout Gantt chart view or line of balance view and could be further optimized. Also, since complete schedule is linked to the model elements, you're right away able to check the animation, so you can see if your work sequence works properly. So if you have some illogical behavior, so that you have to go back to your methodology creation process, so you're able just to visualize the schedule logic right after its creation, and then you can very easily do different scenarios, what-if scenarios of your schedules. You can assess the quality of different schedules, you can visualize the working sequence for different schedules, and of course you're able to modify it. Of course, since the schedule was based on the cost information, the total cost and all the unit prices, all the quantities, all the activities of the schedule are already integrated within the schedule, so you can see the total cost of the schedule right away for every task. You have ability to color code your schedule tasks based on the schedule activities. You have ability to visualize that color coding in the animation as well, so you can actually see color coded model elements based on the tasks for which those elements are linked. You also have ability to change this coloring scheme of your schedule, so you're also able to visualize different task properties. So let's say actual cost, baseline costs for the actual schedule, some constraints, cost variances, schedule variances, schedule performance index, total float, let's say, like in this case. So you have ability to change and to visualize information in both in Gantt chart as well as in animation directly, so that you're going to be able to see different parameters of your schedule quality directly in 3D animation and directly in your Gantt chart or line of balance chart. So besides all of this, you're also able to visualize your animation based on the custom breakdown structure. So in this case, you can visualize it by the uniformat code. So you can see differently color coded different uniformat categories. You can visualize it by the spatial elements like the floors in this case, or the buildings on, let's say, based on the subcontractor as well. So you have unlimited opportunities to visualize and to check all the parameters that are available within the model. You can color code the critical path, visualize the critical path, the elements that are on the critical path, and the most important thing with the task report, since, as we said, the schedule is connected to the cost classification, we have ability to assess the quality of the schedule by simply checking the, let's say, line of balance view, where we can optimize the schedule, as in this case. So this is the same schedule as we have created, just optimized for roughly hour and a half, not more than that. So we can see the striking difference about optimization of the schedule, just changing durations and changing some constraints. We can visualize the cash flow, we can visualize cumulative cost for the schedule, and we can compare between different options. So let's say the optimized options, the option, the version of the schedule that was just created. We can just balance the activities. You can see the difference between cash flow of the optimized schedule and unoptimized schedule, and we can just compare different installments of the schedule, and we can decide which one is the most optimal for our construction process. So after developing multiple what-if schedule analysis and optimizing the final schedule and accepting it as the based planned schedule, user can start progress monitoring process using this baseline planned schedule. So based on this baseline planned schedule, user has ability to manually or automatically create look-ahead plans for a specified period of time, which will include the elements that should be completed, all the quantities, resources, and price of the activities that should be executed in a certain period of time. This information could be published directly to the cloud-based online viewer. Using this viewer, using this application, construction team on site has ability to access this information through a mobile device like a tablet, let's say, to open it, to see it, and to update this information with the actual information, with the actual executed elements. It could save that in a form of BCF file, send it back to Office, and this input information could be used as the basis for the schedule update. So with this updated information, actual progress information, the planned schedule is updated, and it becomes the actual schedule. Of course, 4D, 5D simulation is updated, the earned value analysis, the actual cost, the actual quantities, everything is updated according to the actual data from construction site. Schedule duration is recalculated, so you can see the impact on the finishing date. The user is able to develop planned versus actual analysis. User is able to export monthly payment certificates automatically, and is able to generate reports which will cover all basic KPIs of the project. And of course, based on this updated actual schedule, planner is able to create look-ahead plans for the next period. So based on the actual data on site, you are able to generate future look-ahead reports and to send it again to the construction site for the next tracking period. And this is how the whole process looks like in the Bexel Manager environment and in Bexel Manager software ecosystem. So if you remember, we had ability to visualize our schedule through schedule animation. We have ability to check the pace of animation, if it's going to be on daily, weekly, hourly basis, monthly basis. So with this feature, we have ability to set up the animation intervals to be equal to our look ahead plans or to our tracking period. So in this case, monthly, let's say. So if we set up animation with this pace, we have ability to select the elements for, let's say, every month of execution. So with this selection, we can just create quickly a look ahead plan, a selection set that will include look ahead plan. From the selected elements, user is able to create a BCF file and to export it and send it to publish it to online viewer. This could be done also automatically through the publishing process. So publishing the look ahead plan to the viewer could be done also through the publishing process without use of BCF format. So the on-site team could just open the cloud-based application online viewer and is able to visualize and see the information about look ahead plan. So it could see the elements that have to be executed. It has ability to select the elements that are executed or to deselect the elements that fail to be executed, and has ability to save this information as a BCF and to send it back to the project manager. The project manager can then just simply load this updated BCF with the actual information back into software. It can simply open it, in the same way as it was done in the viewer. It could create a selection set out of this information and just mark it as an actual progress for a certain period of time. In this particular case, it's 1 month. And after that, it can just create a copy of the actual schedule, because you can have incremental copies for every progress, or just use one copy as an actual schedule. User has ability to just specify the range or the period of time of tracking, and just simply select the elements that were executed from selection sets, update the last entered date, and all the information in the actual schedule are updated. After that, user has ability to right away compare the actual schedule with the baseline schedule to see for every task the difference in the time of execution, and to see right away the impact on the completion date of the project. It has ability to check the line of balance schedule to see how it impacted the line of balance. It has ability to check cash flow, cumulative costs, planned versus actual analysis. It could check the resources. It could check the quantities of executed works during the certain period of time, the cost of executed works, and it also has ability to export payment certificates and to export Power BI reports, which will include all basic key project indicators, all put in the Power BI dashboard, standardized Power BI dashboards. All these dashboards could be further optimized, could be fine-tuned, could be customized for every user, for every company, and could be used to report the progress, to report the key project indicators to other stakeholders, to executives on the project. All these information and dashboards include some really important information like cost performance indicators, schedule performance indicators. This all information could be also published to Portfolio Manager, which will allow user to see even a broader picture about key project indicators on one project, multiple versions of the same project, or multiple projects at once. So with the use of the range of Bexel Manager supported applications, we were able to start from the model that even didn't have the corresponding data set, and with the use of advanced BIM workflows, we were able to first enrich this model, to create cost classification, to create scheduling, and to perform progress tracking process based on this schedule, and to complete with the BIM supported reporting and analytics and KPI analytics of the project, and to basically complete an integrated BIM implementation into project from the beginning to the end.